Hi everyone, I am Sam. Today we are going to talk about the Parker Solar Probe. NASA's Parker Solar Probe has made history by surviving the closest ever approach to the Sun, passing just 3.8 million miles from its surface. On Christmas Eve, the spacecraft plunged into the Sun's outer atmosphere, enduring temperatures up to 1,800 degrees Fahrenheit and radiation intense enough to damage electronics. Moving at speeds up to 430,000 miles per hour, Parker's mission is to unlock long-standing mysteries, such as why the Sun's corona is millions of degrees hotter than its surface. This breakthrough could improve our understanding of solar wind and space weather, which impacts Earth's communications and power systems. The successful flyby marks a new era in solar exploration. When NASA launched this spacecraft in August 2018, the world was treated to a historic moment. For the first time, a mission designed to touch the Sun soared into space. It's an audacious goal. The Sun, though critical for life, is a place of extreme danger. Temperatures there can reach millions of degrees in its outer atmosphere, called the corona. Radiation is intense. Yet, the Parker Solar Probe is braving these harsh conditions to help us answer long-standing questions about what makes the Sun behave the way it does, and why what happens on the Sun matters greatly here on Earth. Long before this mission was conceived, an astrophysicist named Eugene Newman Parker made predictions about something few people at the time believed existed: the solar wind. Born in 1927 in Houghton, Michigan, Eugene Parker was a scientist who had a knack for following wherever the equations of classical physics led him, even if the results seemed radical. In the mid-1950s, the prevailing assumption was that space between the planets was essentially a perfect vacuum, empty, quiet, still. Parker's calculations, however, indicated that the Sun must constantly be spraying out a stream of charged particles at speeds of 1,000,000 miles per hour. This was in direct conflict with what many scientists thought was possible. Why would the Sun throw off so many particles into space? Parker's early paper describing the solar wind was met with skepticism and outright rejection. Peer reviewers said the mathematics and the conclusions couldn't be correct. There was even an attempt to block the paper from publication. But a famous astrophysicist, Subrahmanyan Chandrasekhar, who was editing the journal at the time, found no arithmetic errors in Parker's calculations and decided to override the negative reviews. The paper was published in 1958, but acceptance by the broader scientific community was slow. Parker persisted, confident in his math. 4 years later, the Mariner 2 spacecraft confirmed the solar wind's existence by detecting the stream of charged particles flowing outward from the Sun, precisely what Parker had predicted. It was a victory not just for Parker, but for solar physics as a whole. His work demonstrated how the Sun is far from a quiet ball of gas. It's dynamic, often violent, and heavily influences the neighborhood around it. Although the solar wind is always blowing, on certain days the Sun can hurl out even larger storms of charged particles, known as coronal mass ejections. These can travel across space and potentially disrupt Earth's power grids, GPS signals, and other technologies if they hit at just the right angle. Parker's revelations paved the way for a new understanding of our star and a new field of science called heliophysics, which focuses on how the Sun affects the entire solar system. Many decades later, NASA decided to embark on its most ambitious solar mission yet, a probe that would travel so close to the Sun that it would pass inside the corona, the Sun's outermost layer. The corona is famously perplexing. Despite being farther from the Sun's core, it is somehow much hotter than the surface. The surface of the Sun is about 10,000 degrees Fahrenheit, but in the corona, temperatures shoot up to over 1,000,000 degrees. One idea, first proposed by Parker himself, is that countless tiny flares called nanoflares might be releasing bursts of energy that keep the corona superheated. But to properly investigate this, a spacecraft has to go right into that region, an incredibly hostile environment, to gather direct measurements and see what's really happening. NASA's new mission was initially called Solar Probe Plus. However, a key administrator at NASA believed the name didn't quite capture the grandiosity of this voyage. When asked if there was someone deserving of this rare honor, an entire NASA spacecraft named after them, the National Academies of Sciences quickly and unanimously recommended Eugene Parker. He was alive and in his 90s, still curious and excited about the mysteries of the Sun, so it was a perfect way to recognize the man whose work laid the foundation for the entire mission. Thus, the mission was renamed the Parker Solar Probe, making Eugene Parker the first living person to have a NASA spacecraft bear his name. He and his family even traveled to Florida in August 2018 to watch the liftoff. It was a moment of pride and perhaps a little awe, seeing a rocket streak into the sky carrying his name, and the promise of new discoveries about the star that has fascinated him for so long. The Parker Solar Probe's main scientific goal is to dive closer and closer to the Sun and try to solve some of the big questions that still baffle scientists. One is the aforementioned coronal heating problem. Why is the outer atmosphere far hotter than the surface? Another is the acceleration of the solar wind. How do those particles go from relatively slow speeds near the Sun to moving up to 1,000,000 miles per hour as they travel outward? Understanding these processes is important because the solar wind and any larger outbursts can affect Earth in all sorts of ways, from producing brilliant auroras near our poles to potentially knocking out electrical grids if the ejections are strong enough. Yet one of the most common questions about the Parker Solar Probe might not be about solar wind at all. It's more practical. How in the world does this spacecraft not melt when it's so close to the Sun? The solution lies in an innovative heat shield. Engineers spent years perfecting a 4.5-inch thick carbon composite barrier. On the side facing the Sun, temperatures can climb to around 2,500 degrees Fahrenheit, roughly 177 degrees Celsius. That is hot enough to melt many metals. However, the shield is specially designed to reflect, rather than absorb, most of the Sun's intense energy. In addition, the spacecraft constantly orients this shield between itself and the Sun. As long as the shield is pointed correctly, the instruments tucked behind it stay at relatively normal operating temperatures, not much hotter than a cozy day on Earth. The heat shield is shaped a bit like a flat disk to effectively block as much of the Sun's heat as possible, and special radiators on the back help bleed off any stray heat that does get through. Interestingly, the environment just a few million miles from the solar surface doesn't behave like we might imagine, based on our experiences with heat on Earth. If you think about standing near a bonfire, you can feel the heat because the air, plus infrared radiation, carries that energy directly to your skin. However, in the near vacuum of space, there isn't much material to transfer heat through conduction. While the sunlight itself is extremely intense, the thinness of the corona means the Parker Solar Probe isn't constantly bombarded by scorching particles in the same way it would be if it flew through a dense atmosphere. Most of the heating threat comes from direct solar radiation, which is exactly what the shield is meant to deflect. Because the orbit of the probe brings it closer and closer to the Sun over time, NASA planned a clever approach using gravity assists from Venus. Each time the spacecraft swings by Venus, it taps into that planet's gravitational field to adjust its trajectory and speed. This technique gradually shrinks the Parker Solar Probe's orbit, allowing it to zip closer to the Sun's surface on each pass. At its nearest approach, the spacecraft will be just under 4 million miles away from the Sun's surface. A distance that sounds large by everyday standards, but it's actually within the outer atmosphere of the Sun itself, where conditions are unbelievably extreme. The hope is not only to satisfy scientific curiosity, but to gain practical knowledge as well. By understanding the mechanisms that produce powerful solar events, we can improve our forecasting of space weather. When the Sun unleashes a strong coronal mass ejection, the high-speed surge of charged particles can trigger geomagnetic storms around Earth. At best, these storms create dazzling auroras in polar regions. At worst, they can disrupt satellite communications, cause dangerous surges in power grids, and generally throw off modern infrastructure in ways that might take time and money to repair. Better predictions could give power companies time to protect their transformers and let satellite operators manage their fleets during hazardous conditions. Meanwhile, Eugene Parker continued to follow the mission's progress until his passing in 2022 at the age of 94. He was thrilled to see the data coming back, especially glimpses of the solar wind and the bizarre structures within it that his calculations had first described decades earlier. In one meeting with NASA scientists, he famously nudged them and asked, "Have you found any nanoflares yet?" The quest to identify these possible tiny bursts of energy in the corona goes on. There have been hints, and as the Parker Solar Probe sends back more precise measurements, scientists may well confirm that these nanoflares exist, and perhaps confirm Parker's theory that they are responsible for heating the corona to its staggering temperatures. The story of this mission is not just about advanced engineering and cutting-edge science. It's also about human curiosity and perseverance. Decades ago, Eugene Parker trusted his mathematical instincts at a time when many around him said his predictions were impossible. He endured criticism and doubt, yet stuck to his convictions until evidence proved him right. The Parker Solar Probe symbolizes that spirit of exploration. It dares to go where no spacecraft has gone before, braving the glare and fury of the sun, to unlock secrets that have mesmerized humans since we first looked skyward and felt the warmth on our skin. There is still plenty of work ahead. Over the course of 7 years, the Parker Solar Probe will complete 24 orbits around the Sun, using each close pass to gather unprecedented measurements. Every success is a step forward in understanding both the star at the center of our solar system and, by extension, many other stars scattered throughout our galaxy. What's learned might help astronomers better comprehend stellar behavior in general, and how such behavior can shape the environments of planets. In our own solar system, there's a direct link between solar activity and the conditions astronauts might face once they travel beyond the protective bubble of Earth's magnetic field. That's it for today, and I'll see you in the next episode.